Hi guys, in today's video we're going to see two reactions with hydrochloric acid and aluminium metal. To start this reaction, I first need a volumetric flask measuring 500 millimeters with a funnel attached on top. Then I'm going to add 500 milliliters of hydrochloric acid, also known as muriatic acid or drain cleaner. Hydrochloric acid that I am using for this experiment is concentrated 32%, therefore 10.181 moles. Although this acid's concentration seems a bit weak, it still poses imminent danger for burns and is also a major irritant. So, if any handling is considered, wear gloves, as shown in this video. If you notice, I make a mistake and fill too much hydrochloric acid inside of the volumetric flask. So therefore I use a measuring cylinder to pour out some of the hydrochloric acid to reach 500 millimeter mark. Now I'm going to transfer the hydrochloric acid into a 1 liter beaker. I am doing this because the reaction is going to be extremely exothermic, meaning that will release energy into its surroundings, and I am scared that will break the volumetric flask. To start this reaction, I'm going to squash up a ball of aluminium foil, and then I'm going to place it into the beaker filled with hydrochloric acid. It takes a few seconds for the reaction to start since the oxide layer of the aluminium doesn't let the hydrochloric acid react directly with the aluminium metal inside. What starts reacting is pretty evident because it starts bubbling, creating a black precipitate and also emitting white fumes. That is hydrogen gas. You can actually observe the precipitate falling to the bottom of the beaker. Care must be taken when doing this experiment to wear a gas mask or to be in a fume hood, as the gases produced can easily irritate your eyes and burn your throat. I let it sit for a while, and then I place a thermometer inside of the beaker to calculate the temperature.
You have to do.
I thought that the temperature inside of the beaker dropped since I didn't put the thermometer immediately inside of it. So therefore I just added another piece of aluminum foil to restart the reaction and to calculate the temperature more accurately. You can notice that the aluminium reacted much faster this time. This is probably because the acid much hotter than it was previously, thus increasing the kinetic energy. Therefore, the aluminium dissolved and or decomposed quicker than the previous time. Here, you can truly observe the extent of fumes being produced by this experiment, as they can be seen hovering towards the laptop's camera. I put a piece of protective tape over the camera since I didn't want any excess hydrochloric acid fumes sticking to the camera and causing damage. Here you can see me stirring around the mixture and after showing you that the temperature achieved was around 60 degrees Celsius. To work out the balanced equation of this chemical reaction algebraically, you need to follow these few steps. For the first step, you need to set coefficients to the variables of hydrochloric acid, aluminium, aluminium chloride, and hydrogen. I gave them variables A, B, C, and D. To start, you need to calculate how many hydrogens are present in the reaction. For example, for hydrogen we see only one hydrogen as A and two hydrogens as D. So we write it A is equal to 2D. We go to chlorine, where we only find one chlorine in A, but we find three chlorines in C. So we write it as A is equal to 3C. For aluminium, we find one in B, and then we find another one in C. So we write it B is equal to C. Now we need to set a value for a number to start the algebraic sequence. We take B as 1. If B is equal to 1, C is also equal to 1. If C is equal to 1, A is equal to 3. If A is equal to 3, D is equal to 1.5. Our issue here is that we got 1.5, which can't be possible because you can't have 1.5 atoms. So therefore we just make everything times 2, leading us to B is equal to 2, A is equal to 6, C is equal to 2, and D is equal to 3. Now all we need to do is to substitute the values A, B, C, and D into the equation, giving us the balanced equation of 6HCl plus 2Al produces 2AlCl3 plus 3H2. One can notice how two aluminium atoms lose 6 electrons altogether, acting as the reducing agent in the chemical reaction. These form two aluminium 3 plus ions. Here you can notice 6 hydrogen cations accepting the 6 electrons produced by the two aluminium atoms. These form three diatomic hydrogen compounds, which are a gas. I start by adding 200 milliliters of the same hydrochloric acid I used in the beginning. After that, I add some minorly hydrated copper sulfate, which is a bluish color, as you can see here. As soon as it makes contact with the hydrochloric acid, it turns into a pale green yellowish mixture, which is just basically a copper sulfate complex. I add a bit more, and after I start swirling it to mix it around. Once I observe it's all dissolved, I leave it to sit for 10 minutes. What happens next, in my opinion, is pretty cool. Basically, when hydrogen starts the combustion, because I sparked with the lighter, the cupric ions in the air around it combust with it, producing this beautiful dancing blue, purple, green flame. This sludge at the bottom of the beaker is hydrochloric acid, chlorides, including aluminium and copper chloride, and also has got particles of copper that give it a reddish color when shown in the light.